Good morning everyone, I am Mr. Rish. Thank you for joining me. Limit as a approaches infinity, a divided by a minus 1. This specific limit has a very special and important meaning behind it. What is that? Consider what you're seeing right over here. We're looking from here n equals 0 up to infinity, 1 over a to the power of n. What does this look like to you? It looks like what would be a rule for an infinite geometric series where a value would be larger than 1. You'd be looking like values 2, 3, 4, 5, 6 onwards. Something that would be convergent. Look, if a were to be equal to, let's say 5, we're looking here at 1 over 5 to the power of n. When you start expanding this out, what do you get? 1 over 5 to the power 0 plus 1 over 5 to the power 1 plus 1 over 5 square plus 1 over 5 cube onwards. Infinite geometric series which would certainly be convergent. Anyhow, let's get to that limit and let's see what's the special meaning or the hidden meaning behind it. I've told you a is larger than 1. When you're looking at this type of an infinite geometric series rule, you know clearly the common ratio is 1 over a. It's a shortcut, you can remember that. If you were to expand it out, take any term and then term before divide them, do the ratio, you'll get 1 over a no matter what. And now look, when the common ratio is a value less than 1, you know it's convergent. And here I've told you value is larger than 1. So obviously it's going to be less than 1 in terms of this comparison. What will your a first term be? It'll always be 1 over a to the power 0. But what is that specifically? It's 1. If you look at this item over here and you look at this item over here and you bring them into the sum of the infinite geometric series formula, which is a1 over 1 minus r, what do you get? Bring these substitutions, and I've told you a1, your first term is always 1. I've told you your common ratio is 1 over a, so you're looking at 1 minus 1 over a. If you algebraically solve this, you're getting 1 over a minus 1 over a, and then you're getting a over a minus 1. And this is exactly what I'm talking about. An infinite geometric series, as these values of a, the base constant, gets larger, what happens? What are we essentially saying by means of that limit? We're assessing what is the value of the sum. This is what we're looking at right over here. In essence, what we are saying is this: the sum of that infinite geometric series, you can represent it by means of this limit. The value is what? The value is exactly what that sum will approach. Exactly, that's what it is. But as you're approaching infinity, this is what has to be evaluated, and we'll get down to a good clear answer. You're seeing here in terms of a function nothing which is difficult by any means to handle. You can easily handle it using the limiting value of a function procedure, exactly what you would do for a horizontal asymptote. Divide everything by the highest order exponent variable that you see. I have a divided by a minus 1 over a. That's what I'm doing, dividing everything by the highest order variable exponent. I have a 1 over 1 minus 1 over a. Limit as a approaches infinity, I'm looking at an end result 1, and that's exactly what my end result is, 1. But what does this 1 mean? It means this: as these values of your infinite geometric series, the base constant becomes larger, the entire sum of that series will be dependent or will become more and more close to that very first term. And I'll show you why. If I have a rule which is this, from 0 up to infinity, 1 over a to the power of n, but now I'm saying a is equal to, let's say, 10,000. And I told you it all breaks down into this a over a minus 1. If a is equal to 10,000, plug away, you'll have 10,000 divided by 9,999. Do this computation, you'll have a value very close to this. You'll be a few decimal places away, but you'll be very close. Imagine what happens if I start putting like here a billion. Now what am I really going to have in terms of this formula? I'll have a billion over here on the top, and then you know what I'll have in the denominator? I'll have 999,999,999. Do this computation, you'll be extremely close to that. Now imagine what happens as we get so close to infinity, everything will be basically dependent only on that very first term. Because if you expand this out, what are you going to get? 1 over a to the power 0 plus 1 over a to the power of 1 plus 1 over a to the power of 2, on and on. This right here is already equal to 1. These terms right here become so negligibly small. As you can imagine, these values, if you start putting them in the denominator to the power of 1, 2, 3, 4, they become so meaningless, so small. Everything in terms of the series sum tends towards this specific first item, which is your a1 term. That's it. You can even symbolize this. This limit is equal to your a1 term, which will always be a 1. And that right there is the end of this video. Thank you.